In this video, we're going to take a look at how we can use a singular survey feature definition for a point such as a tree with an alpha code of tree and see how we can utilize some new features within our 2018 Q2 OpenRoads Designer release to substitute different cells and different text based on something called attribute overrides. So if we take a look at in our example file here, we have a singular feature definition called tree that points to a singular point feature symbology. And if we take a look then at our element templates that are being called by that feature symbology, we will see that I have a cell that is placed called tree. And that is a singular cell. Now what if, for example, we had different sizes of this tree and different diameters that we wanted to automatically scale that particular entry? So how would we do that? If we navigate down to the survey settings section, there's a new entry in here called attribute overrides. And if I select, I put in a couple of entries here. As you can see, I have the object type. I have either a point feature or a linear feature option. And in this example, we're working on tree, so it would be a point feature. And then you select the feature name operand, and you have different choices. Basically, it's looking for the name of the feature definition, not the alpha code or the numeric code, but the feature definition name. And so it's looking to equate, that it has this word or begins with this word, etc. So I'm going to say that it contains the letters TREE, and that is actually the feature definition name. Now in my case, it's the feature definition name. If you take a look at, it's tree space and then parentheses exist period parentheses. So as long as I have that the feature definition name contains this tree, you'll see that it would match. Then I want to tell it to look for the particular attribute information. And so if I go into a text editor, I have a very simple survey example here that we can take a look at. And in here I have 3 shots for 3 pine trees. And notice that the feature definition or the alpha code is TREE. And then I designate in an attribute the attribute name size, and then I give the attribute value 16 inches. And then I have an attribute name for the type, and it is a pine. And so I have size and type are my attribute names, and their values are 16 inches and pine. And then I repeat that for a 24-inch pine and for a 30-inch pine, but all of them have the exact same survey code, if you will, but we want to basically plot and also annotate 3 different sizes of that particular cell. So what we've done here is in our attribute overrides, we've said if the attribute name is type and it contains the word pine, which in our case it does, then we want to do something different. Okay, so let me go ahead and widen out this value here a little bit and we'll scroll over. So if we have that shot, then we're telling it, I want you to select the element template, survey, point, landscaping, and then tree pine. And you can see I don't even have that in here yet because I haven't mapped. And so that element template would also need to exist in your survey world environment. So I went ahead and created that element template. Now this is just working in my sample test file. You would do this in your survey feature definitions file, obviously. But I wanted to go ahead and show you the difference. And so this was our initial element template that would draw a generic tree. But now what we're doing is making this more specific with a different cell that we want to place called tree pine is the name of that cell. And so if we go back to our attribute overrides, you can see that in here, survey, point, landscaping, tree pine, that is the override element template that we want to use. And you have some different options in here. You can say, well, I want to override it with an element template, or I can use the element template designated, but maybe I want to scale things in both horizontal and vertical, or just horizontal or just vertical. And so that will take into account, if you select something with scale, then that would take into account what we did here in the second row, where we are changing the size of the cell, where we are giving it the units of inches, and then using the value of the attribute field itself. And so that will scale it. Or you can simply just say size, and what size does is just takes whatever size it is and multiplies it times the override double value field. And so that works together. And so you'll see that when we talk about the second portion of this video. But right now, my focus is on the element template. I want to take that to a different element template. So I want to plot a cell called tree pine, or basically use an element template to plot that particular cell. Now, we also remember in our example that we have the same survey code, alpha code, but we have 3 different diameters. So we have the attribute value 16 inches, 24 inches, and 30 inches. And so the idea here is to not have to create multiple survey feature codes, but rather allow the surveyor in the field to select the proper attribute type of tree and its diameter. And so that's what the second line here does, is it's taking a look at, again, a point feature that contains the word tree. Again, this is feature definition, not survey code. And it also contains the attribute value size. And so we will see that we have the attribute value in there called size. And so there's the attribute value size. And then the attribute value operand, if it's not empty, in other words, if they put a diameter in there, okay, then we want to go ahead and use the value as an override. The value is what would be in that raw data. Okay, so in our example, we had 3 different values to use. All right, and then in here, we are going to select on this second row, we are going to size the width, size the height, or size both. We're going to size the width in this example. And so what that's going to do is just basically take that tree size and adjust it to the proper size based on what they put in there. And we put in inches because that's the format that's in the raw data. And so it will multiply or size it to the proper diameter based on what they put in there. Now, if you want to put in your own override values, okay, you would set the use value as override to false, and then you would put the override in the double value column here, and it would use that to do the math. And so that's how this works. And so with this override in, when we map this survey data of these 3 trees, we should see the same cell, but 3 different sizes. So let's go ahead and create our field book here. And so I'm going to drag and drop that particular sample over. So there's this one. And then we'll do a fit view. And you will see then our 3 different trees at 3 different sizes. So if you take a look then at our attribute values, you see this is our 16 inch, this is our 24 inch, and this is our 30 inch, all using the same field code tree and also the same element template to plot that particular cell, but we have the 3 different sizes of our pine trees. Now what I want to do is take this a step farther. What if we had different types of trees where we wanted different cells? So we've already taken a look at how we can resize a singular cell or single element template cell entry. What if we had different cells to place also? And so I've added to our element template list. We started with pine, calling the active cell tree pine. I've added in an entry for a citrus tree, a deciduous tree, and an oak tree. And so those element templates are in place. And now we want to take a look at what I changed with our attribute overrides in our survey settings. And I have simply added in the remaining 3 entries. And so you will see I have an entry for oak. So if it finds the survey feature definition tree and it contains oak, then I want to use, you'll see then the list of element templates. So we have tree pine, tree oak, tree citrus, and tree deciduous, where each of those then, those element templates would be overridden and place different cells, all while taking into account the different diameters that are placed in that particular entry. And so if we take a look at our new survey data set I want to map, you will see, for example, that I have different types of trees in here with different values of radius. And we took a look at how we have, the pine trees for 3 different sizes. And so now we're going to add in a deciduous tree at 24 inches. We're going to add in a citrus tree at 12 inches and then 2 oak trees at 36 inches. And so by using the call here to the different element templates, we can draw the different cells. And then the size is then set based on the attribute field for the size. All right, so let's go ahead and accept those changes. We can close out of the element template. And then if we go down to our survey, I'm just going to delete this field book and then we'll bring in our updated file. So let's go ahead and drag that in now to map those. And so here you will see we have the different sizes of the pine tree still intact. And then we have, for example, here is one of our 36-inch oaks. And so we can hover over that and see that information. And so there you will see that we have in this particular example our 36-inch oak tree. And here we have, I believe that is our 24-inch deciduous. And in here we have our 12-inch citrus tree. And so the attribute override simply allows us to use a singular alpha code or numeric code, and then based on the attributes that are placed in the field, we can then place different objects. And so if I go in and add the annotation to this, so we'll annotate model here and place those, you will see that the labels then take on those active attributes that are in that survey data. So now for the second part of this demonstration, I want to take a look at doing something linear. In our example, what I would like to do is we would have, for example, an entry for a utility. And based on the utility entry, we may select it's a buried gas line or a buried fiber optic line, etc. We can set up the same attribute overrides to use a singular feature definition or survey feature definition with a singular alpha code called utility. And then with that particular entry, we can have it place different lines or draw different lines for us. So let's take a look at a different survey data file where I have basically 4 points drawing 2 lines, where I have a singular attribute set to the type of particular underground utility. So I have a gas line and I have an electric line, both of them using a singular super definition alpha code UTIL, or util for short. And so if we take a look at the feature definition example, you will see I have a feature definition calling the alpha code util, and the feature definition name is underground utilities. Now, if I look at my settings right now in my attribute overrides, I just have the entries in there for the trees. I don't have anything in there for linear. And so if I map this right now, I would essentially be ignoring the actual entries of the attributes. So if I come into my field books and I drag and drop the data, you will see that I have 2 utility lines drawn. The attribute does show me that it is a gas line and this is an electric line, but they both appear the same and they're both going to be on the same level called util underscore miscellaneous, which was controlled by the default element template, which is here, and so you'll see that that's what gets plotted. Now I've set up 2 additional element templates, one for electric, where I have that set to its proper level and color and line style, and then I have one for gas, and again I'm doing the same thing, setting it up appropriately. So now what we do before we can map this, let's go ahead and delete our field book that we just created, and then go back to our standards of our survey settings and go back to our attribute values here. What we're going to do is we're going to add a couple of new entries. And so I'm going to select new, And on this one, it's going to be a linear feature this time, and that feature definition name is going to contain the letters util. We saw that that was spelled out as utilities, and we're going to say that our attribute name operand again is going to contain, and in our field data, our raw data, the word type or the attribute name is type, and the attribute value then would contain the value here, the letters gas, for our gas line. And then what we want to do is select a new element template, and we can type this in. So this is going to be survey \linear \utility \gas, and I will tab out of that, and that's the only thing we need to do on that line. And then we will create another new entry and basically repeat this for our electric line. So again, that's our feature definition name, and it contains the letters of util, and then our operand or attribute name, if you will, is type, and it's going to contain the letters electric. And then we're going to use another element template for that. And it is not case sensitive, so it doesn't really matter. And then you would want to then hit accept to save those changes. And now when we come in and drag our data over to create a field book, so we'll go back up there and we'll drag that in. And now you will see that even though we've used the singular alpha code util, it has read the attribute value of type and then used the appropriate element template then to generate the proper level, color, style, and weight. And so here is our gas line on a level called util gas, and here is our electric line drawn appropriately on that level as well. And so again, this allows you to have one survey field code called util, and then in the field, the surveyor would select what type of utility it is. That would be put into the attribute type name, and then that would be used then to plot the appropriate linear symbology.